So I just want to start off by saying that nothing that lasts is built in a day. Right? It takes a long time for everything to mature from concept to production implementation. Nobody would say that you build Chrome in a day, and nobody would expect you to do so. Similarly, with such a fundamental change in networking, one doesn't know everything in the beginning. You start off, you make some wrong assumptions or incomplete assumptions. You don't even know what you don't know. It takes time and effort to flush out all the issues. It typically takes many years for new technology to go from concept to production readiness. And we believe that now, finally, OF-DPA is at that stage. The whole project, this OpenFlow ecosystem, with Trellis and everything, and core and all are kind of ready for prime time. And we probably still need to do some more work with real carriers, starting field trials and stuff like that to flush out all the issues that are yet to be worked out. I mentioned this because I already hear a lot of talk about the next new thing. So I just want to emphasize that it takes time to build what people started off with a few years ago, and we're finally kind of getting close to be ready for prime time. And this slide further addresses or rather confirms that statement. If you look at even the evolution of OpenFlow, it started back in 2009 with the publication of the first OpenFlow 1.0 specification. It was a single table, all ternary matches. It was suitable for a software switch, no doubt. But when people tried running that on real hardware and tried really running real networking use cases on that, they found a lot of issues with that. And that led to the development, especially with the usage of the single table and the fact that the TCAM is the most expensive resource typically in inside of networking silicon. That led to the development of OpenFlow 1.1, 1.2, and then 1.3 came about in 2012, where finally multiple tables were defined, along with a bunch of other needed extensions or changes and enhancements to the OpenFlow specification, including support for groups and meters. And the idea was to make it extensible to allow vendors and other folks to define their own header and match fields also. 2014, I believe, Joe, that a separate group started off defining TDPs, and they came up with the idea of how to come up with a programming model for a multi-table OpenFlow switch. And that resulted in sort of a formal description of tables, actions, extensions, etc. And the idea was to describe it all in a JSON format that could then be read by the controller and then maybe even potentially pushed down into the switch or read from the switch so that the controller knows the capabilities of a particular switching element that it is trying to configure. So around that time is when Broadcom started working on OF-DPA. We realized that we did not need to wait for a brand new OpenFlow logical switch to be designed from the ground up. We could take our existing switch pipelines and then provide this mapping layer that converted, or rather made the existing fixed function silicon look like an OpenFlow logical switch. That enabled us to implement a TGP for OpenFlow programming while realizing the benefits of these fixed function devices. Line rate performance, different price and power and capability points, speeds and feeds at different points in the network. We did not want a 32 by 100 gig at an edge device, as an edge device. So Broadcom's broad portfolio of products allowed us to map OF-DPA into all different, and I'll show that in a little bit more detail later on, allowed us to map OF-DPA into a range of products in our product line. Furthermore, the Open API specification that we came up with allowed multiple white box vendors to start taking these specifications and implementing OF-DPA on their switches. The evolution of OF-DPA itself, very similar to the OpenFlow evolution. We first started off with OF-DPA 1.0, where we added support for the use cases that were asked of us by the customers at that time. Layer 2 bridging, Layer 3 routing for both IPv4 and IPv6, and some support for VXLAN tunnels. Then we started discussing more with service providers who wanted to use OF-DPA or OpenFlow control networks in their networks. And they were looking at more features like DPWS, MPLS Layer 3 VPN, and various forms of QoS. And Joe will talk about a more detailed feature list that we support in OF-DPA today, but these are the highlights of the different major releases. That was also focused on Strata XGS. And then in the 2016-2017 timeframe, we came up with OF-DPA 3.0, 3.1, various year releases of OF-DPA. And we added support for Strata DNX or the Qumran MX family. And we have some customers who have taken OF-DPA feature set and ported it by themselves to other members of the Doom family. And that is now essentially a code-ready solution. We've added support for some features. We've been working very closely with Saurabh, and we have certainly added a lot of the features that he has asked us. Maybe not every one of them, but we've enabled core, leaf-spine fabric, and relish to get to the point where it is today. And a lot of these features run on various ASICs. As I said, not every ASIC supports every feature in OF-DPA simply because the underlying hardware does not necessarily support that. But nevertheless, we have devices from our legacy devices like the Apollo 2, Hurricane 2, Triumph Plus, and all of that, supporting OF-DPA as well as Trident 2, Tomahawk, Cobra MX. And it's relatively easy to port this existing feature set onto new ASICs, should you need to do so. Okay? And we've also worked with the community to provide a very robust ecosystem around OF-DPA. We've gotten different controllers and agents working with OF-DPA. Some of it we've done internally. A lot of it has been done by our customers and partners. For our internal development and verification, we focused primarily on the Ryu controller because that was available readily when this whole project started. Since then, we have done limited testing with Open Daylight. We actually let Saurabh and his team do the bulk of the testing with ONOS. With Open Daylight, some customers of ours have done a little bit more testing than we have. We have done very limited internal testing. As far as the agent is concerned, we, Broadcom, have focused exclusively on Indigo. And we've actually taken the Indigo code and made a lot of changes to it. Our plan is to upstream it all at some point. It's just one of those things that keeps getting pushed out, but certainly we want to contribute all the changes we made to Indigo back to the community. We work with a range of ODMs. Obviously, Edgecode Acton has been very active in board. Quanta is also now, as Saurabh mentioned, is going to be providing a platform that supports OF-DPA. And in fact, we've been working with them for a couple of years to allow them access to the OF-DPA source code, and they already have it working on a variety of different platforms. And all the other ODMs that are listed here do have different versions of OF-DPA running on their platforms in various stages of completeness. We work with a variety of operators as well, OEMs for their own private uses. We work with system integrators and software vendors who have looked at OpenFlow, adding OpenFlow support to their proprietary solutions and have used OF-DPA as a reference. I'm not saying that all of them have taken our OF-DPA and used it exactly, but our OF-DPA is definitely a reference starting point for everybody. And that's a key point that I wanted to make. OF-DPA as it exists today is really a reference solution. And we do expect people to take it and adapt it to their particular environments and their use cases. In the sense of hardening it to provide all the error checks, error control, potentially in some cases to add missing features, integrating it with their particular Linux environments, adding all the other telemetry features, kind of thing that they want to see added to OF-DPA. Quite often we let our users do what they want with it. So it is not a finished product that Broadcom is sort of providing for marketplace. Okay? And I think on merchant silicon at least, we do provide the most comprehensive OpenFlow support in the industry today. With that, I'll turn it over to Joe, who will provide more details about it.
So I just want to make a few points about a reference solution. It just means it hasn't gone through all the QA cycles. And so there may be bugs. And Saurabh can attest to that fact. And now, it's gotten pretty solid, thanks to more and more use and more test cases out there. So it's still, as we see it, a reference solution, but with some productization that's gone on. So basically, OF-DPA has a whole lot of features in it. We've had a number of constituent customers, if you will, and wanted various things. So like, for example, it started out as layer 2, layer 3 data center. And then what happened was, with VXLAN tunnels. So VXLAN initially, and in fact it still is a configured thing, it's not really a pipeline thing, because that's the way it was originally specified in the OpenFlow community. So the whole idea was to be culturally compatible with OpenFlow, to be able to use OpenFlow controllers and appear as a multi-pipeline OpenFlow switch. that you could program with TTPs, which I'll get into in a minute. So then we started to get a lot of carrier interest, and there are different carrier type networks that we deal with. So one of the big driving factors we had was China Mobile SPTN deployment. And so this added BPWS, it added OAM, it added blind color-aware meters, DiffServ QoS, a whole bunch of things, a whole bunch of features that were driven by that, including like protection, and G8113, and then Ethernet OAM. So these are features that are specialized for a certain kinds of access network, PTN network, as they call it. And these features are used in a lot of other networks, but it's mostly in carrier backbone type networks. In a fabric, it's mostly the data center kind of functions with some lead-in from MPLS, the second round. So there's by all means, this is not exactly everything. There are a couple of more features that are in the OF-DPA spec that are implemented, but that are, we don't have enough room to list. So you've seen this already. I'm not going to dwell on it very much. It's essentially OF-DPA was the first instantiation of the white box switch that enabled doing the trellis, implementing the trellis architecture at scale. So a little bit more detail on the OF-DPA software stack. The agent is Indigo. And as Ashok said, we have some changes to go back into the Indigo code base. These are mostly for some of the changes or some of the extensions that we had to add in for OF-DPA. So it's kind of a historical sort of thing here, but when you look at the way OpenFlow was originally designed, and I don't want to say anything too negative about it, but it was basically a grad student type project. Sorry, I was one of the grad students. This is a while ago to start. And since then, people learned a lot more about how switching works, how networks work. And so one of the things is that if you look at the way P4 specifies a pipeline, it's all metadata. And when you look at the way OpenFlow started to specify a pipeline, it's all packet header. So there was no real metadata. There was a 64-bit metadata thing that you could do anything you could do with it, inadequately small, and no semantics to use. So what we wound up doing was biting the bullet and adding pipeline metadata fields, which is one of the things that came in OpenFlow 1.3. And so there's a lot of these new pipeline metadata fields. For example, OAM classification, things like that. Other things to handle too, VLAN tags. And these are things that are visible to the controller and that would need to be programmed. And so Indigo changes are necessary, agent changes are necessary to make that happen. This is all part of the OpenFlow 1.3 specification, how to do this. And in fact, they're on the ONF site, I don't know if it's still around, but there were a whole library of extensions that were proposed for OpenFlow 1.3 that handle a bunch of different use cases, like tunneling and some other things. So basically, another piece, a critical piece here, is the configuration agent. We've added a OF-config agent. I think it's based on OpenFlow open source net-to-peer code, and that was added as part of the PTN type project. And so now we have a number of UML converted to Yang components for configuration. So all the OAM is configured through this OF-config agent. Then in the, going down the stack, OF-DPA provides APIs for both of these agents. And the APIs are then implemented in the hardware. So, and in different places in the hardware. Some of them are in the hardware switch, some of them are in the PHY, and so forth. But all of that is abstracted out under this OF-DPA API layer. And then this runs on Open Network Linux now, and there's an ONI component to that for loading, for basically loading the switches in the lab or in the network. And then the OCP specified bare metal hardware on the bottom. And then this is provided by, these are available now from a number of different sources, which you'll hear more about later. So what is a TTP here? This is a picture of the TTP pipeline. And there are a lot of TTPs here. You'll see a version of this, which I have later in here reproduced, which is used in programming fellows. But there are all of these different components that are basically used in core. I don't know, have you seen the QoS marking?
Not yet, but we need to.
Okay, all right. So that's available now. VLAN cross-connect was added. This is the ability to switch a layer 2 packet based on the VLAN tags without looking at the MAC address. And that's a carrier feature that's been supported in the hardware. So most of this exercise was taking a lot of the features that are in the hardware and exposing them in a OpenFlow pipeline, an OpenFlow API, if you will. And then, like, we have the VXLAN VTEPs, which all the overlay is done through OBS currently in Trellis. And we have a plan or discussion to bring out some of the termination components for VXLAN in the future. But this is, we have to make some surgery on OpenFlow to do that. And then there's no need for OAM protection switching, protection failover, stuff like that. We also had added stats counters. So like for Ethernet OAM and Ethernet deployment for E-line type services, they need statistics counters based on, those are the color counters, and then there's the label counters for the for the switching path. These were all added. This all makes use of the hardware that's there. And then currently major platforms that are supported are Tomahawk, Trident 2, and QMX. We have a number of other platforms, including all the ones that we use for the carrier features that are not really part of the core case. So in case TTPs are an abstract concept, there's a JSON file that describes all the tables, all the actions, all the forwarding. And this is all machine readable and usable and debuggable. So all of the OF-DPA TTP pictures, really, those are informative. This is the normative piece. And this is basically something that you could then translate into APIs or translate into whatever you want, really. So there was an ambitious plan for a while in Open Daylight, the TTP project, which is sort of defunct now, which was taking the JSON description, used a Yang parser and parsed that into a back-end, consumable Open Daylight component. It never went beyond that. So I mean, basically what we can do is take the tables and draw a nice dot, make a dot file and draw a graph type table. But that's about it for now. But it could extend this into doing whatever you want. So we wanted to extend this to be able to basically auto-generate APIs if needed, or the OpenFlow southbound piece, much as what Carmela's now doing with P4 runtime. But you need resources to do this kind of thing. QoS and mirroring, just as a little aside, we had to invent meter bands that actually were industry standard for IETF standards. So the hardware supports all this stuff. This is the case that the carriers all like to use, which is this modified three-rate, three-color. And I kind of flashed it up a little bit. The diagram in the spec is not so pretty with the different colors. But basically, you have a green band, a yellow band, and a red band. The green band is when you don't do anything to the traffic. The yellow band is when you exceed or you fall within a certain range of traffic rate. And the red band is where you basically are out of performance. So, and usually that winds up dropping the packet and doing, some other instrumentation type of stuff. So basically, this is the meter bands here were completely redefined from the way they were defined in OpenFlow, and you can check the OF-DPA spec for the details on it. The other thing that's not so well understood is groups and egress tables. So groups are really form a number, do a number of functions here. One of which is encapsulation in egress. Those are the indirect tables that will do things like push MPLS labels on and stuff. For ECMP, there's select group types, which basically use a hash function to select what you want to do. In the hardware, the hash function is very configurable. In OF-DPA, it's basically fixed. We take the most common case of how the CRC hashing is done over what headers for IP or L2. But that's all really configurable at the hardware level. And we can bring out, if we need to, a configuration API that'll do that. They're all groups, which are multicast replication. And that's usually done in a packet buffer kind of engine and stuff like that. But in the pipeline, it's presented as something that happens after the last ingress table. Excuse me. And then for protection switching, we have a fast failover group. And this is based on port liveness. This was a particular challenge to adapt into the OAM failover, but if you want, catch me after, I'll explain to you. And then OpenFlow, after 1.3, around 1.5, they added egress tables. And egress tables were something we really didn't need, except that it comes in, it's necessary for the carrier use cases. So like for things like you can do egress hackles and egress VLAN translation, but the main thing was we could do an egress OAM table. So for Ethernet OAM after you decap the packet. This is another version of the same TTP that appears, or similar to the one that appears on the ONS port site. Basically, it's the same tables. So actually, I pulled this out of a different presentation. Oh. I got time by there. So anyway, this is just some things we did with configuration, VXLAN tunneling. For QoS port configuration, basically OpenFlow did not have a good way to specify how you do QoS and queuing, on port-based queuing. So what we do is we have a configuration which is an augmentation to the OF-config Yang model. OF-config, by the way, is like, if you took the union of the ITF interface and system and all that other stuff, they made one for OpenFlow, or OpenFlow capable switches. And so we then augment the ports in OF-config with things like scheduling properties, scheduling mode, and so forth. We can also do hierarchical scheduling, but we haven't added that yet into the spec. This is an example of the UML that's in OF-config, and then we augmented that with MIBs and all the other stuff for OAM, plus some other configuration stuff. So this is a marketing slide.
So basically, we've given hopefully a little bit of a flavor of what we've done with OF-DPA so far. We've started simple and added a lot of use cases over time. And we do believe that there are significant benefits of using OF-DPA as listed here. We certainly enables the usage of OpenFlow 1.3 on the switch architecture that .com provides. And not only one member, but the same program or the same application can be ported to run on many different ASICs that we have in our portfolio. The second thing is that it definitely leverages the ASIC hardware tables to deliver line rate performance. Nothing is really being done in software in terms of getting packets flowing through the pipeline. And we've also, as Joe has mentioned, we've been able to extend OpenFlow to expose features that are supported in the ASIC, such as the QoS and others, which were not originally part of the OpenFlow specification. So we've come up with a lot of new table types, a lot of match action extensions, and things like that, and implemented them. We've actually contributed a lot of these changes back to the OpenFlow specification. And Joe and Ray Chung from Channel Mobile, along with a bunch of other operators, have come up with this technical standard where they defined a bunch of NPRF extensions, etc., to support the SPK use case that is now an ONF technical standard as well. And this openly, we think that our ability, or rather our willingness to publish the APIs has accelerated the development of OF-DPA solutions among OEMs and others. Certainly OF-DPA code is not open source, but the APIs are open. And we do provide the code to everybody that asks us that has the right SLA in place with .com. And in general, we want to make sure that we want to continue to play a leadership role in the deployment of OpenFlow-enabled solutions. And we are committed to making enhancements to OF-DPA as necessary to push Core and Trellis and Core and other OpenFlow-based projects forward. Okay. And now I think we have time for some questions. So if you have any questions, feel free to ask. Yes.
In addition to meters, has anyone asked for shaper support?
Yes, that's the queuing support is there. So we do strict priority. We do WRED. That's all configurable through the configuration API. We only brought out one layer of queues, queuing basically. So OpenFlow basically has min-max queues, which are not very useful. But you really need to have the congestion control. And then, like I said, the hardware supports, pretty much all the hardware supports 3 levels of queuing, hierarchical queuing, and that could be brought out if needed. But it's not really needed in the core case, at least so far.
So far, but there are more and more people asking for it, so it has to come up someday.
Yes.
Question from Kevin. Are there any new releases of OF-DPA planned and will be supported on newer silicon from .com?
It depends upon market requirements. If somebody wants tomorrow to say we need to support on Tomahawk 2, we certainly are willing. And in many cases, if it's the same family, we have had customers and partners who have actually taken our existing OF-DPA code and ported it to a additional silicon member by themselves. For example, I don't want to name names, I suppose, but we have had customers who've taken it and ported it on Vitamin Plus, on Helix 4, and other devices, and not spent the time to because the feature set, especially if it's the same feature set. If it's new features that the silicon now provides that you want to sort of bring up to OF-DPA level, that requires a little bit more work and more expertise. And we are willing to look at those on a case-by-case basis.
So we have so many chips, excuse me, like Maverick is a 1 pipeline Triton 2.
Right.
And so we did not support that chip, but we had a customer who did it himself, just took the code and did it. I'm sorry, you had a question?
Yeah, yeah. So it seems like it requires a lot of work, like to map right the OF-DPA logical pipeline view to many switching ASICs you have. If you consider adopting using let's say other APIs and other ways of specifying your pipeline, for example, use TTPs. If you consider using P4 to specify the pipeline, if you consider using P4 runtime as an alternative to OpenFlow.
So I should ask if you've considered P4 runtime mapping to OpenFlow, but rather than to RPC protobuf. But it's a similar kind of thing.
Yeah.
Yeah, we have actually, and looked at different approaches. And there's some issues with P4. It's not very good hardware description language for something like an existing pipeline, existing hardware. There are a number of things that it's missing. So I'll give you an example. We have, OpenFlow has this hack they call Synchronized Tables, okay? And we use that. And in fact, we use that for like Mac lookup and Mac learning. So you can do the source Mac lookup, the destination Mac lookup. The control plane sees one Mac table, okay? In P4, I haven't figured out a way to express that. You have two tables, and the control plane writes one, and then there's the element of surprise, because the other one's going to get updated magically by the hardware. So this is a thing that P4 would need to be fixed to be able to handle. There are other places where you have to express everything as a table in P4, and basically we have a lot of logic decoding functions that say, yeah, it's multicast. Yes, well, that's a very simple case. But then when you look at like anomaly detection, SIP equals dip, then you have to contort how you express that in terms of a bunch of tables. So things like that get difficult to bring out in P4. We have tried.
Okay. Right.
And we could express it in TTPs. TTPs are a little bit more fluid.
Well, but the flexibility of, so I'm not an expert of TTPs, but at the slide you showed before, I saw some English language. So there were some parts that were saying, okay, this starting from OpenFlow 1 to 3, this field is like not supported. So it seems that like you bring in flexibility by not completely formally specifying certain parts. So it seems there's still some ambiguity in the way you specify your pipeline using TTPs.
There's no ambiguity. There might be incompleteness.
Yeah.
Okay, if you look at it that way. You might need it. But the thing is, all those extensions are legal OpenFlow. Now, another cultural issue we ran into is that this isn't OpenFlow, this is TTPs, So you say, what is OpenFlow? So now you look at P4, you're defining your own pipeline. TTPs define a pipeline, And basically you can take these table descriptions and turn them into OpenFlow southbound calls. This is all done manually today, but
Okay, thank you.
anyway.
Is there a plan to refresh your GitHub with 3.0?
3.0 binary?
Well, yeah, binaries and also the definition, because the last time I looked, it was still on the 2.0 GA level, which is a little old now. So
Yeah, we're looking into that. I mean, we've been moving a little bit fast and for various projects, so we haven't really focused much on that. But we will take that into consideration. I don't have a time.
The 3.0 spec is on the Broadcom site. I don't think we put it on GitHub. And then the SBTN spec is someplace now, I don't know where.
Right. The other thing is, a lot of the stuff that we did publish on GitHub, the binaries were specific to, not exclusively limited to, but were fundamentally focusing on our own testing case, the Broadcom verification cases. And now with more and more ODMs developing code that's getting ready to publish their binaries, we do have resonance with them to allow them to put up some of their binaries in the domain.
It's like
like we
So the need for us to do that especially on platforms that maybe the community is not using as much now. We felt were a little less urgent to do so.
So do you have a roadmap to release the OF-DPA version?
So the roadmap, I didn't show specifically the roadmap slide. A lot of that is, we are working very closely with core. So we definitely want to make sure that all the core features that are necessary to be implemented as part of the roadmap. And then we are working directly with some of our end customers also who are defining features. So a lot of those tend to be specific to their customer's use case. So yes, we do have a roadmap. I haven't shared that publicly because a lot of it is still in flux right now. But we are committed to supporting all the OpenFlow projects that are going out there. Many of them have approached us. In terms of devices that we're committed to add support for in the near future, we actually, to be honest, we haven't received any requests from anybody to add support for some of the newer ASICs like the Tomahawk 2 or the Diamond or whatever other devices that are out there. But as I said, if it's porting the existing features, it's relatively easy to see. And OF-DPA in many sense is doing something that is our response to the community's requirements. So if the community has a specific set of features, then let us know, reach out to us and we receive them.
Okay, thanks. Let's thank the speakers.